Hello everybody. Today I'm going to explain one of the projects that I've been working for the last 2 to 3 years. It's not really an app or a plugin, but it's more of a workflow or at least a template that you can use to recreate chroma information and to a certain degree spatial information in a faded or damaged print. Now, in this particular example that I'm going to show you today, it's going to be about chroma information. The spatial information, I will try to make another one that is more successful because the ones that I've done and the ones that I've been showing are not like 100% archival quality ready. But let's go with the chroma-recovery because I'm really confident that this workflow works. First, to set the scene, this footage by a person on Instagram, and you can clearly see what is happening here. Obviously, the scan doesn't have a lot of information. It's quite faded. I would say it's like a bit skewed to yellow. And obviously, it has a lot of, flicker and blue dust and the like. You can clearly see that there is some sort of ghosting. So similar to what we did with the color cleanup. There is something similar happening here. Okay, so before we start, if we want to try to make something out of this, we need two things. First, we need this source to be balanced and or cleaned. I don't have time to clean this in restoration, but I'm gonna balance it. And the other important thing that we need is a reference. So a reference may be a video, a lower gauge film, or wherever we can get the color reference of the movie in a previous state. So the person that gave me this shared as well this. So this is the previous state of the movie. I suppose this was, it says beta. So you can clearly see here and we have all, if not most of the color information. The reason that I want these color references is because they were done close to the creation of the movie. People may argue they are not the final color reference, at least they have less degradation when they were created. And to a degree, most video outs from this period were usually supervised by somebody in production. So there is some sort of final color reference to them, at least from what I understand. And you can clearly see here, even though obviously the quality is less, it has a lot of compression artifacts and it's not as high quality as the film, and it's obviously a bit short on the sides and on the top and the bottom. It has all the colors as they were. So this is our target, and this is the reference that we're going to use to create our machine learning model in order to try to recover that color. So like I told you before, the first thing that we need to do is either to clean up or to balance the source footage that we're going to be using. We're going to go to one of my timelines that I made here. This is the original footage as it came. And now what I did is basically use two plugins. Most of you may be familiar with my faded balancer DCTL. So I'm in the process of releasing this, another version that is basically the OFX version of the faded balancer. It should have the same capabilities plus the ability to create custom presets, and then I will add some more things in the future. If you try this with the DCTL, it should give you exactly the same results, so no problem there. Basically what I did here on this step, let me turn this on, is just aligning the red channel. You can clearly see here that I didn't touch the blue channel because I made a lot of tests in this footage. And something that I realized that if we see the original, and I want to show you the original. This is the red channel, this is the green channel, and this is the blue channel. The blue channel has a lot of issues. Some issues are so problematic that in most instances, they are unrecoverable. Now, is there some information of the blue channel that will be possible to use? Yes. If you wanted to create just a balanced version without doing any kind of machine learning, yes, the blue channel can create more information. The only issue that will happen is that it's going to generate a lot of small artifacts where the blue channel becomes brighter or darker in some scenes. So you may get a normal scene looking, and then you will get like some sort of yellow stain going in and out or up and down, because that's the nature of how the layer is right now. So I took the decision, in order for me to properly clean this, I needed to get rid of the blue channel. So basically what I did is a channel replacement. I replaced the blue channel with the green channel. and then adjusted a couple of bits of the green and the red, and that was basically it. So I have an output like this. It's not perfect, it looks like a two-strip Technicolor, but at least it gives me a better starting point to trying to make, you know, some sort of recovery. Now, there is a lot of flicker going around here. I mean, to be honest, if I wanted to do this properly, I could go look to a proper tool like Diamond or Phoenix to do the Deflicker. But just for the sake of keeping everything resolved, we're going to use the Resolve Deflicker. Now, the Resolve Deflicker, it's not bad. If you control it to a degree, it can be really useful, and it really doesn't generate that much artifacts if you know how to use it. So you can clearly see here, it looks really good. And to a degree, sometimes it looks better than some of the expensive Deflicker tools. And it's not generating that much of an issue. I mean, it's mostly trying to equalize all the levels, so I think it's working fine. And mostly I'm using this just to stabilize the channels before doing any type of machine learning, because if we have these kind of jumpy frames all over the scenes, you know, the mapping of the machine learning model may become way more difficult. In general, like, it's really hard to do this if we have all this running around. So we need to have some sort of a deflicker. That's what I'm telling you, that it should be clean to a degree. I mean, if you notice, we haven't touched any of the dust or dirt running around there, but it's at least an advance to what it was before. I mean, to be honest, the flicker here is really damaging. And again, if we go back to the original source and we see each channel, even the red channel has some flicker, the green channel definitely has flicker, and the blue channel had, yeah, it was probably destroyed. It didn't have even contrast. In this kind of footage, you have to make a compromise because you cannot get it all at the same time. I mean, this is not an original camera negative stored in a studio vault in Hollywood. It was probably an indie movie, or maybe a commercial movie that was stored improperly in India or something like that. Obviously, due to the climate and the conditions where it was stored, this damage worsens and you get something like this. So different regions have different issues with film, so we cannot treat everything as we can get the maximum amount of quality, like we were working with the Wizard of Oz camera negatives. No, this is like, it is what it is. So, and as long as we acknowledge those limitations, we can start working on them. And I think we can get something out of this. I'm not being pessimistic, I'm just being realistic to a degree. Okay, so now that we have this, we're gonna create, like you probably have seen this, I created a timeline. So in this timeline, I'm gonna have, this is the source that we're gonna use, and this is the reference. Now, they need to align. We need to align them. I wouldn't say to a perfect pixel location, but they need to be aligned temporarily and then spatially to the maximum degree that we can accomplish. A good way to do this is basically doing a difference. You can create a difference mode between A and B, and as long as A and B are within the constraint, you should have something good. There are some places, and this happens all the time, occasions where the different elements, when they go through different iterations or they go through different generations, they warp or they contract, and they have like different levels of geometric distortion that may not allow the alignment to be 100% accurate. But as long as we have a rough starting point, we should be okay. Now, if we need to do some manual warping later to perfectly align, it's gonna be painful, but that's something we may need to do to properly get the model working. In this case, I think the alignment is really good because seems like they were using, or at least I can say it's a similar element that was used in this latest source that they scanned with the beta tape that we have here. And also when they recovered the original frames out of the video, they got the original 24 frames. Because something that happens as well is when you get a tape or a magnetic reference, most of the time it's going to be interlaced. So the issue when you have something interlaced is that those frames may not follow correctly to the source. So as long as you can do a pull down, and that pull down comes clean because you have the original flags that were used to do the conversion, if you get the original 24 or 25 frames out of that, anything that you do is going to be perfect. And you can clearly see here, if we go step by step, this was a really good conversion. So there is no combing artifacts, nothing that will signal that this was interlaced at some point. You cannot really notice this anymore. So a good reference or a reference that we can clearly recover the original frames is something really important as well. Can you work with an interlaced reference? Yes, to a degree, but you will be limited by the frames that properly align. So in this case, we can use whatever frame we want. But in those cases, when the interlace was poorly done, or the interlace is still visible through combing in some places, we may need to pick and choose the exact frames where there is no interlacing, because that interlacing is going to mess the machine learning model. So we align these two, and then we create an out. Now, usually when I create a sequence out, I usually do it in EXR. I like EXR because it's a lightweight way to do image sequences. I usually do RGB half DWAA. I mean, you can do this in DPX, yes, but I don't like doing it in DPX because the issue with DPX that I usually find is that they are way too big and the quality, to be honest, is not that different for this kind of film. I mean, obviously, you're working in an archival environment and you want to keep it all DPX. Yeah, do that, but you need to have the proper storage and the bandwidth to play all of this. Now, to be honest, in a lot of VFX pipelines, they use EXR. I use a compressed version of EXR, but even then, it's not really that, you're not losing that much quality. This will be similar to a ProRes 444XQ, so, or even a bit higher sometimes, because you have 16 bits here. So I prefer to use EXR. So I create a sequence out of the source plate and I create a sequence out of the reference plate. Now, something to be aware of is that if you can see here, the source, it's obviously bigger and you have all this space here. And the Betacam source was around 720 by 566. So, and we are aligning them. And basically what we are doing is putting this 720 by 576 movie in a 2048 by 858 container in order for us to have a perfect alignment. Because if we were to render this in its original resolution, what will happen is that when we go to Nuke, we will need to align them again, and it may create more issues than it should. So if we are doing this preparation step and we are already separating each cut and we are like doing this whole thing, might as well put the reference into the biggest container that we can. Now, in some cases, the source is not going to be 2K like you see here. Maybe the source is 4K or bigger, and we do the same. Some may think that this is a waste of space, but to be honest, I had better results by doing this here in Resolve than trying to do this on Nuke. Just a word of caution. Okay. So now we render that and we finish this part in Resolve. So now we go to Nuke. Now, in Nuke, I will provide a template. Now, that template is going to be in a GitHub repository where I explain most of the parts that I'm going to show you here. It also has some parts about the spatial recovery, but I may need to update them because they are not 100% accurate. I'm going to expand on this view so you can clearly see. So when you're getting the template, you're going to get all of these parts and they're going to have the names here and everything. So it's going to be self-explanatory, and also I have an operators, a descriptor, so you can see what each part is doing at each point. Now, the first way that I'm going to do this is by using the whole sequence. Now, there are two ways to go around the CopyCat training. So you can do it shot by shot or sequence by sequence. So when I first start working with a film or with a project that I need to do a color recovery, I try to do sequence first. Then I do like a large training, may take a couple of hours, maybe a day. And then from that result, from that inference, I can see which shots may need more or less time in shot by shot training. So this is basically what I did here. So if we go again here, let me zoom here and try to squeeze this a bit more so we have more information. We have equal information. So this is the target data set. It's basically the number of frames that we're going to be using. It's basically the whole sequence. We have the whole sequence here. As you can see, it goes from 1 to 7351. And this is the source. Let's go step by step and I will let you know why I'm doing the things that I'm doing. Immediately after the target or the source dataset, we have this retime. This retime is basically multiplying or speeding up by a fixed factor the number of frames that we have here. So we are started with 7,351 frames, and we are multiplying this by 36, so we get at 205 frames. Okay, so now after this, I can show you what is happening. So this is all the frames that we're using. Now, the number of frames of the factor that you're gonna be doing for the frames really depends on how well is the model integrating with all the parts of the film. Now, this was a project that I was helping this person in Instagram, so I'm not really like doing this for a paid job or an archival project, but basically just to teach. So I just took 200 frames because I felt that was the better way to do this. And then these append clips or this frame range that you see here, I'm gonna explain them a bit later once I go to the next part. So this first part is called the dataset creation. The dataset creation is basically gonna be how many frames or how many segments. In this case, since we are doing the whole sequence, we are not talking about individual frames, we are talking about segments. So let's say I have a sequence here that goes from frame 1 to frame 47, then another frame range that goes from 49 to 84, and so on and so forth, that it goes to the end from the 200 to 300. Remember that we already multiplied this by a factor of 36, which made this sequence that was 7,355 frames, it converted it into a 205 frame sequence. This is how we do it, but I'm not telling you yet why are we doing this. This is going to be in the next thing. Now, this dataset creation must be exactly the same in both the source and the reference. That's why it's important to do the resolve step accurately, because you need to align them both temporarily and spatially, and also to the frame number. It's better and it's easier to have frame 21 on the reference and frame 21 on the source being the same frame number. This is frame 21 and this is frame 21. So it makes things easier. You can take different source frames, yes, but you have to take that in consideration, and you may have to create retimes and offsets and whatever to try to make it so they work together. Because when you go to CopyCat, you are gonna need to have the same number of ground truths and sources in order to start training. So all of these steps that we're doing here are to prepare for the CopyCat training. Okay, so we finished the dataset curation. Now the next step is going to be the alignment. Now the alignment really depends. It could be really fast and it could be really, really slow. Now it all depends on how well did you do the spatial alignment in Resolve. If it was just a couple of pans and scans, that's good. If you needed to be doing warp, then it's going to be like really difficult. Now, in this case, I'm going to use something that is called F-align. Now, F-align is kind of tricky. Sometimes it does its own thing. Sometimes it doesn't really care what you want to do. But I found it when you leave it at default, especially, and try to do all these things at the same time, it works better. And also, in case F-align doesn't work, I created a dissolve here that will just bypass this F-align, and instead of going through an F-align, we'll go into a normal transformation. And that normal transformation, you can create keyframes and you can align it whatever you want. The sequence that we want to align is the target dataset, because obviously the source is going to remain as it is. But we want to align the target, so when we do the proper CopyCat training, we have a pixel-to-pixel translation. In order to check that this alignment is doing correctly, we create a difference merge here. So this difference merge is just gonna take IA minus B, and it's gonna tell us if it's working or not. Now, you can clearly see here that all of our alignments are either okay or as good as they can be. Now, other thing that you're gonna see here, that in some places I have created like keyframes. So these keyframes are gonna enable or disable the dissolve depending. So if you see here, starting for frame 164, we get this weird alignment, the final alignment between A and B is completely wrong. If I wanted to keep these frames, if I wanted to keep frame 163 inside of the composition, I will need to bypass the dissolvency. Instead of going to 0, I will go to 1. So it's easy as that. And then it goes to whatever you want to go. So it's nothing that complicated. Starting from frame 163, we are skipping the F-align and we are going straight to the transformation node. So it's only for 1, 2, 3, 4 frames. Okay, if you have noticed, when we get to frame 169, then it stops, and we are supposed to be having 200 frames even after the retiming. So what happened here is that there were a lot of parts in the sequence where I didn't get a proper alignment. So instead of me just doing dissolve in and out of every single frame, I instead took what frames were being properly aligned, what frames were not, and then based on that, I created these frame ranges. So these frame ranges are basically generated because I felt that if F-align wasn't working, I could create these frame ranges that will avoid that frame or those couple of frames. That's why I go from frame 1 to 47, 49 to 84, and so on and so forth. Instead of doing these frame ranges, could I just go here into the dissolve and just turn it on and off depending? Yes, I could have done that, but I wanted to have a better alignment, and I think the F-align provides a better one. Now again, both workflows are valid, and when I show you the shot-by-shot CopyCat composition, I'm doing this dissolve in and out just to keep things working. So this is the reason why you have the frame range. Again, I could have not done this at all and then just go, again, seeing these whole sequences play out. I could just go here and play it and disable or enable the dissolve, whatever I wanted to. Now, let's say we finish the alignment of the target dataset. Yeah, we have something like this. Let's go to an actual frame that I'm using. And now I need to crop. Now, cropping, because obviously you can clearly see here, we have a lot of information on the side. This is the frame that we have, 248 by 58. And this is all the negative space, all the black space that we have on the side. So there is a lot of information here that we don't want to use. And also, if we try to use this while doing our CopyCat training, it's going to generate a lot of issues. What I did here is basically, I created a crop that is going to take only the exact parts that we need. Now, this crop cannot be only used for the target. We need to have the exact same crop for the reference. Now, that's why I created a clone. And you can clearly see this. There is a lot of orange lines in my composition, and there is an orange line going here. And you can clearly see there's orange lines everywhere. There's an orange line in the retime. There is an orange line in another crop that we have here. And there is a lot of orange lines that you're going to see. Because I need them, sometimes I need the source and the target to have the exact same setting. So the good thing with a clone here in Nuke is that if I change the setting here, it automatically changes the same setting on the other one. They are tied together. That's why we have the orange line. So the same crop that I am applying here, I can apply to the source dataset here. So we have kind of the same picture. Okay, now we go to the CopyCat training. And the CopyCat training is kind of straightforward. I mean, to be honest, most of the operations that I'm doing here are kind of normal cleanup operations, just trying to remove channels, trying to align some channels, or trying to get rid of extra information that I don't really need for the training. Now we have the target dataset that is aligned, so we are taking a postage stamp out of this place, and then we take the source dataset that is coming straight from the dataset creation, and then we just pipe in the crop that we have here. A step that I usually take, sometimes it is gonna vary, is that I take this obviously aligned information and I pass it through a median. Now, a median, and you might think that this is way too destructive, is gonna eradicate any high frequency information on the footage that you put it. So it's gonna create this kind of Vaseline-like filter to everything. Basically, what I'm trying to do here is get rid of all high frequency and some of the medium frequency information. Because obviously this was magnetic source, and you can clearly see it has a lot of artifacts, a lot of compression artifacts. And these compression artifacts, if I try to train on top of them, they will come up and they will disrupt the training. All of these things are gonna disrupt the training, so I need to get rid of them. So I'm doing something really aggressive, this median. Now, from this medium, and you're gonna see what happens after, but because it kind of makes sense when we combine them together, that not right now. So after that medium, I'm doing a color space. Now this color space is gonna do something interesting. If you check the settings, and also this is in the operators as well, you can clearly see them on the GitHub. What I'm doing is basically going from a linear color space to a YCbCr. Instead of going from the normal RGB, composition, I'm going to YCbCr. YCbCr extracts the luma information and puts it in one of the channels. So let's say, if I go here to the median and I press RGB, red, green, blue, red, green, blue. Okay. If I go to the color space that now I have converted it to YCbCr or YUB, this is the luma, CB or difference with the blue, and CR difference with the red. So these three are doing something completely different. This is all the luma information from that clip, and this is the color information from that clip. Now, obviously, what I want out of this specifically of the reference is not is spatial information or is luminance information, because the luminance information that I have here is way better. It's higher quality and higher resolution spatial information or luma information. But obviously the chromatic information that I have is close to zero. And you can clearly see here when I go to this color space and I press luma, CB, this is the difference with the blue, is zero. You don't even have a difference with the blue because our blue is just a copy of the green channel. We don't even have a difference. It's almost zero information. If you scroll around here, you may not find something. Now, difference with the red, you get something here. It's at least it's kind of a silhouette here. It's not really that fancy, but at least you have something. GB. Green and blue have exactly the same information, a bit more or less luminance, but it's not really something that will change a lot of the color information. What I'm going to do next, that's I think one of the important parts. So I'm going to do a shuffle node. And then in this shuffle node, basically what I'm going to do is take the luminance information from the source, meaning the high quality luminance informations, and I'm going to pipe it into the luminance information of the target. So basically I'm going to keep the CB and the CR, meaning the chroma information, out of the reference, and I'm going to insert the luminance information from the source. That way, what I'm getting is basically the source that we want to recover the color from, plus the color of the reference. Same source, same resolution, with the color of the reference. So you understand what I'm doing this. Now, you can clearly say, oh yeah, we can call it a day. Yeah, you just render this and that's it. I mean, yes, this operation is basically a color composite mode. It's something that you could do even in Resolve. Now, the problem with this color composite mode is that, again, we are only using 200 frames. This is not aligned to every single frame. Two is that, obviously, there is a lot more information here on the source than the one that we are processing here. There is way more information on the original source than the one that we have here. So if we wanted to make, that's why we want to create this model, because that model is going to learn all the patterns from the color here and apply it to the color here. From this model that we're going to create, we can apply that model we train on this specific point to here, to the full source. So that's why we're doing this. And again, if you only needed to represent the size or the framing of the reference, you can do this on Resolve using a color composite mode and it will work. But basically, this is a color composite mode. We are discarding the luma information from the reference, replacing that luma information from the one that we have in the source. So you can clearly see we're going here from linear to YUB or YCbCr, and then from here we're going to YCbCr to linear. So we are not doing something really, really fancy. A couple of extra steps for cleanup that we have here is basically a grade node. This grade node is just only gonna do a black and a white clamp because, to be honest, CopyCat doesn't really like values that are above 1 or below 0, so we do this. And then we remove the alpha channel because, again, we don't need that extra alpha channel. We don't need it for training, and it's going to take more inference time, and it's going to take more training time, so we don't need it. And at the last step, I'm going to try to copy the B-box. The B-box is kind of the render box that we have here in Nuke. And sometimes when you do this kind of grading operations and the median and everything, the B-box gets amplified. Sometimes that B-box changes between the source and the target. So that's why I do this kind of copy B-box, so they have the same B-box. But all of these three are mostly like optimizations that I found over the years. So to be honest, the most important parts are here. Now we go to the CopyCat. In the CopyCat node, again, this is also in the operations folder. In the CopyCat node, we're basically creating a training folder. And that training folder, I am training a batch step of 3. Now, you can do auto batch sizes. Sometimes I do that. But the problem is that I try to keep things repeatable. And for me, keeping things repeatable means that I can use whatever machine I have at my disposal, because I have multiple computers with different GPU configurations. And obviously they have different VRAM capacities as well. So if I can just make it so I can get exactly the same result out of the different models, I try to create. That's why I set up a manual batch size to 3. And then I make this variable something static. And from that, what I usually change is the number of epochs. Now, obviously, if you are only doing this on a single computer, you can just set this to auto, and Nuke will auto calculate the VRAM that you have, and it's going to create a batch size. But usually, if you have more than 8 or 10 gigabytes, depending on the size of the composition, you're going to get something like 3 or 4, maybe 5, 6. Regarding the epochs, I usually change this because I want to reach a number of steps. No, so I know how long training 200,000 steps or 100,000 steps take. Usually it's like 6 hours in a 3090. I want to reach that goal because I know that I have like 6 to 7 hours to train this. So I try to move these numbers so I can achieve that number or something close to that number. I know that 3,727 epochs will get me around 200,000 steps, and that will be like 5 to 6 hours of close maybe of training in the 3090. I know that I can account for that. Now, if you have more time and if you have like a machine that you can use more, and you can increase the number of epochs. So obviously for this number of frames, it may be too low because we are training 200 frames. And also, if you check the crop size that I have, it's 512. So it's creating 1, 2, 3, 4, 5, 6 segments, or maybe more, into the whole picture. It may not be enough to just train everything or every single part. But again, this is a test that I did. This is not a professional job. Maybe in a professional job, you can increase and you can modify these settings. These are starting settings. I try to keep the checkpoint interval at 10,000 because if you set up the interval lower, then it's going to stop doing the training. It's going to compare it to the image. It's going to apply the inference to the image preview that you have, and it takes more time. So I try to keep it in a place that I know is going to be something that I can have an immediate result between the different intervals. And the contact sheet, yes, I keep it at 100. I mean, it's not optimal as well. But in the contact sheet, you can clearly know if your model is converging or is doing whatever it needs to be doing. So if I show you the progress for the model, I created 2 versions. One is 100,000 steps and the other one is 200,000. The 100,000 step one, it was here. When I was training this model, I felt like it wasn't doing all that much because when I trained this model, it only had like 100 frames. So it wasn't doing that good of a job. Now I increased this training to 162 frames, and then I went all the way to 200,000 steps. Now they landed on the same place here on the chart, because this is where the 100,000 step ended, and this is where the 200 step ended as well. But yeah, you can clearly see when you get to see the final output of the inference that obviously the 200,000 step one is of higher quality. And also, yeah, I will probably just go a bit higher than this if I wanted to do this job. But also, when you're trying to do training on a whole sequence, you need to time or you need to schedule this kind of long trainings, because if you wanted to do this properly and to a degree that it will be like the highest quality possible, you will need to do this on a shot by shot basis. But in this case, I needed to do this sequence. if you do this and it takes like 2 to 3 days, and then you get like a really bad result, those 2 to 3 days probably will have better been used than just doing it shot by shot, and you will probably be halfway done of the whole process right now. So it's something to take in mind. Now this is the contact sheet, and this is the preview. The preview is usually, if you see here, it's just an image that we take from the main sequence, from the long main sequence. So let me show you here. So this is the long main sequence. We do a small crop. This small crop is just going to take out any black borders or whatever, but you're trying to keep as much of the frame as possible. And then you pipe this in a frame hold in this 3600, and then from that I'm doing the preview. So every 10,000 steps, this preview is going to give me some information on how the model is looking. At 3090, this takes like 6 to 7 hours. And then finally you get this inference file. This inference is just the result of the training that you just did. I pipe this into the inference render step. This is the original sequence, the whole sequence, not the 200 frame sequence. This is the original frame sequence. You can clearly see here, piping it from the original input. So this is the original sequence. We create a crop because we need to crop this in order to just do the inference on the place that matter. Now, can you run the inference on this? Yes, but it's gonna take all of these black borders and it's gonna make a mess out of them. I tell you from experience, don't do that. Don't waste your time doing that, and just don't waste computer power in doing that. So we run the inference, takes some time, depending on the computer, and you get something like this. This is the approximation of how the model should look with this. Now, since I am in the Nuke non-commercial version, I need to frame this to 1080p in order to render this. And then I render this and I get this sequence. Obviously, this sequence is the whole movie, so I'm just playing the first 200 frames. But when we go back to Resolve, I will show you the whole sequence. Now, there is an extra step, or I will say like a control step that I usually do, the MatchGrade. So if you don't want to go to this whole thing of CopyCat training and the like, you can also do like a lot. It's not perfect. Sometimes the result is good, but most of the time it's not perfect. So same thing, we take the target dataset, cropped and aligned. We take the source dataset, cropped and aligned, and we run it to the MatchGrade. So the MatchGrade node is kind of an interest node. So it can't create a lot out of the difference between the source and the target. Now, the issue here is that it works really good when it's in this mode. In the auto analyze per frame mode, I would say it's kind of perfect. I would say it's the maximum ability that a lot can achieve. The only issue is that both sequences need to be exactly the same size, because when you are doing the auto analyze per frame, you cannot export anything. It's a process. So it is a live node. But in contrast, when you're doing this MatchGrade using the analyze reference frames, you just choose which frames you need to analyze, and then you can create a 3D lot out of that analysis and use that lot to influence a whole sequence. So it's obviously it's more of a hands-off and it's not running live, but it's not going to be as good as quality as the other one. So if I can show you here the result, so this is the source and this is the source with the color match, which is okay. I mean, it has the same contrast and everything than the original, but it's not recovering the color information. Which if I go here and here, you can clearly see the difference between the both of them. And don't mind the contrast, because that's something that you can play with in normal color tools like Resolve. But see the colors. We are not recovering anything, even though obviously it looks better than the original source. You haven't recovered any of the colors that matter. So it's useful, yes. Sometimes I do it for my own things, but it's not perfect solution. So I usually copy this MatchGrade that I created here. Now, before doing the MatchGrade, I go for logarithmic output, because I feel like MatchGrade works better in a logarithmic space than they do in a linear space. So I try to do this conversion first. Then I again take the source dataset. I just copy this MatchGrade, so it's going to have the same settings. You can crop it, format it, and create an output. So that's why. So I usually create these two outputs all the time because I already have all the steps here. So this is an optional step just to know if it's worth doing the whole CopyCat project. So this is what happens when you get the whole sequence in CopyCat. So let me go back to Resolve. So this is the initial output that we have combined with the source, cleaned and balanced. And the only thing that we're doing here is using the composite mode color. So basically we're taking the output that we got and we're using the color composite mode. And the color composite mode is basically the same thing that we did on Nuke, just doing without all the extra step of the color conversion, but it's basically that. We use this color composite mode so we can combine the color out of this top layer with the color of this source balance layer. So we get something like this. And for the most part, it's going to be looking well. You can clearly see there are some places like here where it obviously it needs more time or it needs more frames. I wouldn't say which one is it. Sometimes it's both of them, sometimes it's just frames, sometimes it's more time. It's a guess game. This is an imperfect science at this point, but at least you know that you can get to a degree that you can start just pinpointing which frames need more training and which ones doesn't, and so on and so forth. Maybe you can add those frames to the sequence, or maybe you can create a new project with all those independent frames. So one of the frames that I was having a lot of issues with, and I can show you here. So I had a couple of issues with this one because it was, you're gonna see it right now. There is a lot of issues here. The dress comes in and out of color. The background as well changes colors. So, I mean, there is a lot of issues here that needed, I don't know if they needed extra time or extra frames. So how do we solve this? The best issue to do this, instead of just trying to add more frames to the whole thing or add more sequences to the whole thing, is let's do another copycat, but just for that shot. So again, we just take that shot, we do initial frame range, trying to do one frame. So in this frame range, instead of doing a retiming, we're doing a frame range. In this frame range, we're trying to just limit the number of frames to 1. So basically, we are just training individual frames. And we're going to do a frame hold for each individual frame that we want to train. I usually use 4 frames. 1 at the beginning of the sequence, 1 at the end, and 2 roughly in the middle, something like that. I used to do 3. But then I realized that most of the time I don't do 3, so I end up doing 4 because it gets me faster to where I need it to go. So in this case, I'm going to take this frame, this frame, this frame, this frame, this frame. Now there is a lot of trial and error because I knew that this dress, especially the dress on this girl, it was the biggest issue, I think. That dress always didn't converge properly, so the model would be struggling a lot to properly resolve that dress. Then it's basically the same step, but when we go to alignment in here, yes, I had to go to the dissolve. When you get to the dissolve, you can clearly see all the keyframes I had to do. So if I go to this frame, I was using the F-align, and then from this one I was using the normal transform node, F-align, back to F-align, back to F-align, transform node. And really depends which one looks better, which one has better alignment. I want to be as accurate as possible, just to make the model behave better. You can do this with the 200 frames. Feel free to do this. If this is your job, this is something that you have to present, do it. I'm just here doing testing. When I need to do this for an actual job, I try to be as careful as possible. Okay, now we go back to the training. It's the same steps that you saw, just instead of 2 sequences, we are just using 8 frames, as you can see here. And the number of steps, I'm trying to keep it 10,000 steps per frame. So if I go to 30,000 epochs with a batch size of 3, I get these 80,000 steps. So basically, in this case, I'm trying to get it so it lasts like 3 hours, maybe 2 to 3 hours. So that's something manageable, I think. And then in this case, the MatchGrade render, I don't really use it because it's only useful when you do it for the whole sequence. If you try to do it for each individual shot, it will take you forever. So I wouldn't bother with this. But then I create this inference and I can show you the results. So now to show you how it looks, the updated version, this is the final output that we created. As you can see, we fixed most of the issues with the blue dress. I mean, it's not perfect, but it's way better than the original was. Also, there is a couple of blue spots that were in the original one that have been fixed by doing this version. So again, there is a lot of things that you need to do in order to create, I would say, a proper recovery of the color of the image. It takes a lot of trial and error, and obviously there is a lot of process here in Resolve and Nuke. So I wouldn't say that this is something that you can apply willy-nilly to every single project, but as long as you know the steps that are available, and obviously I'm trying to help to improve this workflow because I am the only one doing this at the moment from what I know. I'm trying to improve this by letting other people know how to do this. So if anybody has any other ideas, or if they've been trying this, just let me know, and we can just compare notes. I'm not, I would say, a full-time compositor on Nuke, so I know my way around it, but I'm not a professional. So there is a lot of things that we need to improve. But again, this is the idea. So if you have any more questions, just let me know. And I'm happy to help more other projects. I mean, obviously within the time constraints of my normal work, but I'm happy to do that. Hope to see you next time. Bye-bye.